What if you could make things in the world that people would use in their lives? What if you could empower the world with your tech creations and abilities? This is all powered through the process of coding, otherwise being a developer or programming in general. There's a big misconception that coding in general is pretty difficult to learn and do, and that only smart people are able to do. Well, here I'm going to be able to teach you how you can learn to code, and feel free to even learn more if you like it. So, without further ado, let's get into it. If you haven't been to my channel before, I'm the Technetic, and here I show you how you can mod your tech and your video games. You can get started on that by subscribing, so you never miss a video. So we can get started by breaking this process into 3 steps. Find a language, learn a bit of it, and just repeat. The last step might feel like overkill, but in reality, most people do not like the language that they first choose, or they want to keep trying other languages to find the perfect one. If you actually find your perfect language, if you keep going through that process, you'll be able to keep learning about it using some additional resources that I'll be talking about at the end of this video. So, also, you might not be intrigued by any language in general, and you might not think that coding just isn't for you. This is completely fine if that happens. Some people might turn out to like coding, and some might not. It's completely normal. Firstly, we'll get started on what language you should learn. This task might feel a bit overwhelming, mainly because there are tons of languages out there, and they all might feel like the right choice. In reality, the language that you want to learn really depends on how you want to use it. I'll get started by listing some departments that coding can be utilized in. Some examples are making websites, making desktop apps, making mobile apps, using artificial intelligence and machine learning, and creating software for integrated systems. If you want to try making websites, you should learn HTML, CSS, and JavaScript. If you want to make desktop apps for Windows and Linux, then learn C++ and C#. If you want to make apps for Apple devices, like iPhones, iPads, and Macs, then you should learn Swift. If you're going to make apps for Android, then learn Java, or even Kotlin if you want to learn quicker. If you want to make games, then you should learn C# and Unity. Maybe if you want to go further into game development and make AAA games in big companies, then I suggest you learn C++ and Unreal Engine, but that's only for a later stage. If you want to learn AI and ML, then you should go with Python. Finally, if you want to make software for integrated devices, then learn C. Wow, that was a lot to go over. I'll have these on the screen, so don't worry if you feel a little bit overwhelmed. Well, you should be sure to think these options over, and don't be afraid to go with your first choice, because you might even not like the language. However, languages like Java, C, and C++ tend to be harder than the other languages listed. However, don't let this discourage you, as I'm not stopping you from trying them out. In fact, I started with C++, and I was able to follow along and keep learning. Because there are tons of languages that I listed above, I will be providing brief mini lessons for Python, Swift, and JavaScript. If the language that you chose isn't one of the options that I listed, then feel free to skip to the section where I talk about some useful resources to keep learning, or just check the description for some links. But now, let's get started. Alright, so the link to this website is replit.com. You could just try typing in repl.it and it'll automatically redirect you to replit.com. So you can see code, create, and learn together. So in this photo you can see what it looks like and all. So we can just start hitting by sign up or log in. I'm gonna go with sign up. You can choose any platform. I'll start off with Google because it's simplest. Once it loads, I'll select my channel because that's the account I used. Let this load in, and I'll be redirected. There. So you can just give a username. I'll just do Technetic. Just make this anything you want. Doesn't really matter though. And then it'll say that you can choose this email or you'd like to change it if you'd like. I'll go with it. And it'll say what's your skill level. If you're like fresh new, then just go with brand new and all. But I have some experience, so I'll go with some experience. And it'll just say what you're most interested in. Just honestly put this, that's how it recommends different things for you. For me, I'm just here to teach you guys, so I'll just do that. And if you really want, you can go with other stuff. When you're done with that, hit next. And just it says here. So you can just choose the languages that you've been considering. Or if you're thinking of other languages, then feel free to go with those. I'll just select the languages I know for now. And that I'll be teaching. So JavaScript, that pretty much counts as Node.js. I'll talk about that later. Python, and where is Swift? Swift. You see there's also tons of other languages. Don't really select those if you don't really know them. Only select these if you're are interested in them or you know them. So I'll just leave that here and scroll down. You can just leave this and you can just go home now. Alright, so I got that warning, you might not get it as well. So, so as I mentioned before, I'll be starting off with JavaScript. So, I can just click on this plus button, and you see JavaScript, Node.js. For this one, just go with JavaScript. Node.js is a separate engine for JavaScript. In this video, I'm not really going to explain what that really means, but feel free to do research on that at another time. And just give it whatever name you'd like. I'll just call it Learn JavaScript. You can choose if you'd like to. Okay, so I guess you're locked to give it public. So just public, and you can just hit create REPL, and this will create a new environment for you. There. So you'll be given an index.js file. So, as here, there's going to be pretty basic. And I actually have a certain order that we're going to learn the basics about. So, we're going to get started about learning about data types. You know how in the English language, or just in general, we have different types. Think of it that way. We have words, characters, numbers, and more to go. So, for example, in JavaScript and really any other language, words or characters, those are referred to as strings. So, a string can be marked by a quotation. So in REPL and other text editors, it'll create another quotation. And in these quotations, you'd write some words. So I could write a sentence, for example. So this would be considered as a string, but in the English language, it's considered a sentence, or a collection of words. I can even run a simple function, a keyword. So in JavaScript, there's a thing called type of. So I'll just remove this and write type of. It's just one word, and you can see it turned blue, meaning it's a syntax. And here I can hit space, and I can just send anything, like a string, and I'll just type in hi, if I hit run, it will run this code, and here it returns a string in the console. But there's also things as numbers, and in JavaScript, numbers are simply referred to as numbers. So what's different about numbers is, instead of writing them in quotations, I just wrote a number. But the console is still rendering it as a string, because it's encapsulated in these quotation marks. But if I remove them, and I just write the number itself, you see it turns another color. And now when I run it, it returns a number. It doesn't work like this with sentences, since you can pretty much write anything you want. If I type in something like hi from here, some words are considered as like keywords in the language itself, which can cause lots of trouble. So just to prevent an additional error, we'll just do hi here. And we'll hit run, and we'll see that the console should return an error. C says a syntax error because it thinks what we're writing is code. So now you know some data types, strings and numbers. But there's other things like dictionaries and lists. But those are more on the complicated side, and just for easy access, I'll refer to them as lists. Well, in JavaScript they're referred to as arrays, but lists are what they're called in other languages, and I'm just used to calling it lists. So a list or array is set by these two square brackets. You don't really use them outside of the English language, inside the English language, but here you just use them. So in here you just write elements, for example. This can store pretty much any type. So you could put strings and numbers. So I'll just put one element for now and call it hi. If you want to put another element, you'd separate it by using a comma. And here you'd put your other element. So I did hi, then 8, then hello, and then 12. There. If I run it, you won't really get anything because it's considered valid syntax. And here, it'll just return it. And you see there's no error. So, now what we can also do is print these to the console. While REPL kind of already does it, but that really defeats the purpose if you're using it in any other language, for example. So if you're using in any like framework or anything that you have to like debug, for example, it can help to log stuff so you can just know what's going on in your code. So this is easily achieved by doing a console, which refers to this console object, and there's a function, and you can access it by doing dot, and you see we have a bunch of functions that we can access. So to actually print it, or really log it in this statement, we would do console.log, and then what you want to send. So if I want to show hi, I'm the Technetic, I could do hi. Okay. So if I run that, you'll see that it'll run it and it will log hi, I'm the Technetic. The same thing can also be achieved by printing numbers. So the thing is, you don't have to wrap them inside of strings, so you can just write it normally. So you can do console.log and then any number. Let's do 6. And we can go here, and you can see here it's 6. You also notice that if you're printing a string, it's actually white. But if it's for any number or special data type, it is a different color. See, I made it string, it's white now. So that's just a common thing in console. It's just to help you differentiate the type. Now we can go over a certain part called making variables. Think of them this way. You just give different objects names and refer to them as that, rather than rewriting it every time. So for example, let's say I have to type in this long sentence. I'll just grab one. Just look up a long sentence. And it'd be a pain to refer to that over and over again by copy and pasting. Here, how about just, we can just, copy and paste this. That's just for example. You don't have to do this. So I can have this. Here, let's wrap them in double quotes. Single quotes work, but it's not considered best practice. So you see this is a string. What if I wanted to keep console logging this about 5 times? So console.log, and you could just do that, but for 5 times you could just copy and paste, and copy and paste. There. So it works. If we print it, you can see it is successfully able to do it, but in the code it doesn't look that neat and it can be quite confusing. So instead we can give this a variable or an alias just to make it easier for us to refer to. So I can copy this, go at the top, and create a new line, and you can create a variable by using var or let. In a new feature in JavaScript that was added was that if you just want to use this as a variable and you don't want it to change, you can use the keyword const for constant. So we're not going to really change it that much, it's just this. So for now, we can just make this a const. So constant, and you can just give it a name. In general, you can just give it like any character or anything to keep it concise, but just as readability, it's not really good as a good practice if someone was to read over your code. So you want to give it a good descriptive yet brief name. So I could just give it sentence, and to actually give it the value, you could do an equal sign and then just that value. So I already have it copied and I can just paste it. Alright, paste it, and there. And now what I can do is I can remove this and replace it with sentence. And if I just remove this, just for reference, as you can see, we still get that same thing because we refer it as sentence. So that's pretty cool with variables. You can really store them as anything. It could even be a number. So if I was to change this from this to maybe a long number, now if I was to run it, I'd get that number instead because I changed the value. So variables are pretty cool, and they can save you tons of time when working in big projects. But speaking of helping us save time in big projects, there is another thing which is known as a function. So just create one by typing function and then just a name. So let's just say my function. Then put 2 parentheses, then a curly brace. So let's just delete everything here and we can work from this function. So a function, what it is, so like if we do console.log, log in its own is a function which performs an action in a way. So like when we do console.log, the action is that it prints it. But in reality, the code powering this is pretty complex, going into the system centers and just making it do that directly from machine code. But it'd be a huge pain to keep writing that over and over again. So like variables, instead of just assigning values, you can assign different blocks of code which do different actions. So actually instead, if I wanted to, for example, print this, if I wanted to print a number and a sentence at the same time, I could just do a string and a number, and you see when I run it, I get that. But I can combine these two to be my function. So inside of these curly braces, you pretty much say what you want to happen when you write this. So I can remove this, cut it, and paste it. And it's always a good practice to have them indented, just so you know what's inside what parameters. So, as you can see, if you run it, nothing's gonna happen because we don't actually call this. It's just telling the console, oh, I want this to do this. But now if I call my function and put the 2 parentheses at the end and I hit run, it will actually look at this and say, oh, I want to run this. And you can see it ran that too. So just looking at it, all really it has done for us is really just add more lines of code. But trust me, when you do more bigger projects, functions really save you tons of time, especially since you need to reuse them. So just for example, we just did string and 1, 2, 3. But other stuff, we're probably gonna, for functions in real life, you're probably gonna use them for probably doing a big calculation or handling a check, for example. And speaking of calculation, I'm gonna show you how you'll be able to do some basic math operations like adding, subtracting, multiplying, dividing. So pretty much in math, when you want to add something, you would just do a number plus a number. And using math, 6 plus 6 would normally equal 12. But the console can also do math on its own. So we can actually show this by doing console.log. Ignore that. Console.log. And we can actually ask the console to add these 2 values. So let's do something basic, for example. Some mental math. So what if I wanted to add 6 and 6? In our head, we know it's 12, but when we hit run, so does the console. And this can be pretty handy, especially when you're working with huge numbers, and it just isn't feasible to work with those in your head, especially when you're working with all these huge mathematical stuff. So, for example, if I wanted to use, if I wanted to add 1 million and some random number, so 1. And I wanted to add another number, just that. And let's just splice up the numbers. So, normally we'd have to just do this mentally or use a calculator or show our work. But the computer can do this instantaneously. It's like a calculator on its own. And you see we got a good value. So it doesn't just stick to addition. We can do subtraction. We subtract these 2. It loads. I think it's because I'm getting a negative value. If we do something basic like 6 minus 1, and I run it again, I get 5. And same happens when I use big numbers. I can also multiply using the asterisk, so 6 times 6. That would equal 36. And we can also divide these 2. And we'd get 1. There, like that. So you can pretty much do math like this. And just with this knowledge, we could create a calculator that adds these 2. We can use our knowledge from functions to actually add them. So let's say I have 2 variables. A is the first number, which is 9. Okay, const A equals 9, and we have another variable called B, which is 6. We could create a function that adds these 2, and we could say console.log, and you could do A plus B. And now what we could do is we could just call this add function. And you can see it adds these 2 values, 9 plus 6, which is 15. Without us actually writing these in its own, we could just have this one function which calls this on its own. So that pretty much covers the basics of JavaScript. And don't worry, there's tons of other stuff that you can learn. There's literally millions of other stuff. There's also dictionaries. I'm not going to teach you about that now. It's a little complicated. Imports. Like I said, there's tons of stuff to learn about. And now I'm going to teach you guys about Swift. Okay, So if you got Swift as the language that you decided to choose, you can also create a new REPL. So you could just hit create and choose your language, Swift. And you could name it whatever you want. I'm just going to name it Learn Swift. And hit create REPL. Now you see this. Or that's not a feature. So over here, so I'm not sure, after watching this, you probably did not check out the JavaScript section. But if you did, then you can probably, I'm gonna explain some stuff that I already did in the JavaScript section. So you can pretty much, so if you haven't looked at it, so like in their English language, there are also different types of like words or stuff in our English language. For example, when we have strings, strings, which is pretty much English words or sentences in our English language, or numbers, which are integers in Swift. So pretty much strings and integers, those are pretty much the words and numbers for us, but for the computer language. So strings or sentences or words can be created in these double quotations. So inside of these, you could just write in a sentence, for example. This is a sentence. And this is regarded as a string. However, if you want to write a number, which is referred as an integer, you don't have to write it inside of this, because instead the compiler will actually interpret it as a string. So instead, you could just write the number itself, and it'd be able to read it just fine. But you can't really do this with English words or strings, because if I write a word that might be confusing to the compiler, like I am from, actually, how about, let's just think of I love to do stuff. As you can see, do is highlighted because it's a keyword in Swift that I won't be covering in this video. But if I try to use this in any way, the compiler won't understand, because it reads it as code in its own. So you need to actually wrap it inside of a double quote, and there. It's all a separate color, so you know what to do. So now we have to know how to print data to this console. So in order to do this, as I'm saying print, the function is pretty much called print. And I could go here, and I could just say what I want to print. So I could print I could do I love sentences, and it'd run it. So it's see? So it ran the Swift file, and it says it pretty much printed what I wanted to do. I wanted to print I love sentences, and it did that to the console. I can also print integers, and I can just do 6 or any number in general, and when I run it, they'll still be able to run it. And you see, and it doesn't even matter, so even if I wrap this in double quotes, I'll get the same response. But when you're doing math and all, you can't really add strings, so it's better to read them as integers. Now I'll be teaching you about variables. Variables are pretty much aliases for different values, which, when used a lot just for reusability and data, you can create variables which save tons of time. You can do this by keywords known as var or let. So the difference between these two is var pretty much is mutable, meaning I can change this value. So if I do var x equals 3, and I do print x, and I want to change this, x equals 5, and I want to print x, if I run this, it changes successfully. Because it prints 3, then it changes the value, then it prints it again. But if I change this keyword to let, meaning this value can't change, and it's only 3, now if I try to run it, it returns an error, because constant, you can't change it. And even the console set itself changed let to var to make it mutable. So this can be pretty handy if you're using this just as reference. So if I had a long paragraph or anything, double quotes, I'll just write some gibberish. Just imagine this is an example sentence. If I was to reuse this over and over again in my coding project, it'd be a pain to just rewrite it or even just copy and paste it. It wouldn't be as readable, and you won't even know what it is if someone was just viewing this code. So you're better off just giving it a variable. So now if I do print and I just say this variable name instead, it will print it. And notice how we didn't have to wrap this inside of a string. Because since we create a variable, now the computer will interpret this as this instead. Because X, while it isn't just a plain keyword, now it's pretty much you're creating a code keyword. And when you write it, the console thinks, this, oh, he means this, for example. And you can see in the console, I got exactly what I wanted. So that's pretty cool in a way, because it just makes your life way easier in general. And there's also another way that you can also just save time. So with variables, you're able to pretty much save values in general. But there's also a way to save blocks of code. Like if you wanted to have a way that you could just print a number adding a number rather than just writing. So if I had two values, x and y, and I wanted to print adding these two, if I print it, you see I get 7. But if I wanted to just have it one function, because this is a function, I can create my own using the func keyword. And I can give it a name. I'll just call it my func. Passing these two parentheses to let the compiler know it's a function. Then curly braces and what you want this to happen. So I can select this and I can indent it. See, now when I run it, it's not going to run anything because nothing's actually being called. All we're really doing is just declaring this. So when you do func my func and you're doing this, you're just letting the compiler know that, oh, when he means this, he means to do this entire chunk of code. So now if I can actually run this function by just writing the name, then the two parentheses, and as you can see, when you run it, you get what happens in here, which is pretty cool. And if you want to make an app like a calculator and all, it can easily be accomplished by doing functions. Speaking of calculator, now I'll be able to show you how you can do basic operations. I kind of already showed you with the x plus y, but that all makes it easier just for you to understand. In math in general, if you want to add two values, you'd write it as a number, then a sign, and then another number, and in your brain, you would compute that as adding them together. And using mental math, we know 3 plus 3 equals 6. But the compiler also knows how to do math itself. So if I print these two numbers, you can see the compiler is able to print 3 plus 3 as 6, like we can. And we can also expand this to all of the 4 operations. So subtraction, if I wanted to subtract 3 minus 3, it'd be able to do 0. If I wanted to multiply these 3, I'd be able to do so. And same with division, and it keeps going on like that. There, 3 divided by 3 is 1. So, I mean, that's pretty much all of the basics. It pretty much gets, I wouldn't say it gets more complicated, but it gets more advanced, and there's tons of other stuff that you can do. There's also lists, where you can store separate values and separate them by commas. There's dictionaries, which pretty much look exactly like lists, except that they have a value with them. Like that. Like that. But it just keeps going on. but that's pretty much what it is. And it goes further by adding other code that people write with functions that make your life easier. So like one that Apple has for making iOS apps is called UIKit. And one class is a UI view controller. If I try to use this, since I don't have Apple's packages locally installed, it won't run. See, if I try to do, you're not supposed to understand what this means, I'm just using this as a reference. If I wanted to create a class called myController and use Apple's class definition that I have, if I try to run this, it would return an error because it says it doesn't exist. But if you install these modules off the internet, you'll be able to use them, which is pretty handy. But finally, let's kick it off with our last programming language. So this is the last language, and from the deciding thing, if you decided to go with Python to learn artificial intelligence and machine learning, then follow along with this tutorial. So I can hit Python or with this plus button and select Python from the drop-down. Give it a good name. I'm going to just make it learn Python. Hit create REPL, and it'll create a different sandbox so I can write Python code. And you can see it's just initializing. There. So here, similar with all programming languages, if you haven't seen the other two, there's these things called types. Think of it this way. In the English language, we have different types, like words, characters, numbers, all these rational numbers, integers, all this other stuff, really. So the same thing occurs with these other languages. So if I wanted to tell the console about like a sentence, if I just tried to write it in plain English, like I am a sentence, you see you see how it says invalid syntax, because it thinks this is supposed to do something in reality when this is just a plain sentence. So these data types are called strings, and in order to mark them, you want to wrap them in single quotes. See, now you can see it turns a different color and there's no error. Because now the Python interpreter knows that this is a string, like a sentence. But what if we actually wanted to show this on the console? There's actually a function known as print. And you can see even Python knows what we're trying to do. So we can do print and just did that sentence that I want to do. So I could do print, I am a sentence. And if I run it, it'll know that I want to show this. And see, it did it. Pretty cool. But this also expands to other types. Like, if I just wanted to show some numbers instead, what you could think that we could do is just write the numbers inside of this quotations. And if I run it, you can see it'll run likewise. But if you want to do other mathematical stuff, like if you wanted to add this with another number, it wouldn't just work out. So, with numbers, you can simply just remove the quotes, and you can see it changes a different color, because Python knows that this is a different data type. So once I hit run, you can see I got that same value. But if I try doing another operation on it, this number will mutate. So what else we can do is make variables, which are simply aliases for different values. So I can do this by just writing the name and then an equal sign and then what I want. So in other languages you have to say, like, I want to create a variable, the name, and I wanted to give it a value. But in Python it's as simple as just writing what you want to name it and then the value. It's just pretty simple. So now if I tried to print this, I'd get that, which is pretty interesting, because it's able to save it into its memory and then show it to us. So this also works with strings and other stuff. So if I did hi itself, so if I printed hi, then it would just work. It's pretty cool. And that's it. So there's also another scope called functions. So what functions are is pretty much like how variables store different values. Functions are able to store different lines of code or actions, for example. Like you see this print function, as it says this function is responsible for taking the value on pass and showing it to the console. The people who wrote this language created this as a core function, and the code behind this would be very confusing. If I go to definition, okay, ignore that. But if you were to look at the source code for Python and found the definition for print, it'd be a wicked long thing going in the machine code and telling it to go here. So we have these little functions that make our lives easier. So just by creating one, you just write def to define, then the name of the function you want to give it. I can just give it my function. 2 parentheses to let it know it's a function. Then, unlike in other languages you do curly braces, instead in Python you just do it's as simple as doing a colon, and I can hit enter. So as you can see when I hit enter, you see it creates an indent for us. So what this indent tells the interpreter is that right after this colon, it tells us anything I write that is indented will pretty much be regarded as something that belongs in the function. So if I were to write something like if I want my function to print hello world, for example, and I called this function, it's as simple as just writing the name, and I do the 2 parentheses. See, when I run it, you can see it pretty much regards it since it is indented, and I can even fold it just so it knows. But if I actually removed this indent, you see there is an error because it says it expects it to be indented since there's a colon right after. And you can see when you try running it, it says there's an indentation error. Maybe you can fix this by just going to the beginning and hit tab to indent it again. And it's all fixed. So it can get pretty much more complicated from here, for as long as you want to do. So you could have a function that you wanted to, for example, print my name is and then whatever, and then you wanted to keep doing it differently. So if I want to do my name is my print So I just did something a little silly. So normally, in order without this function, you'd have to write this to the console 3 times, and it'd interpret it as this. So if I was just to remove it, so I just so you see since it's indented, it's returning an error. Remove those indents. See, if I print this, I'll get the same response. I'll get my desired response. But putting it inside a function makes the code cleaner, and it can save a bunch of time when using this over and over again. So I can create it again. And I can just indent these. Go down. Indent it again. However, when I don't call it, see, it doesn't do anything because we're just defining it. It doesn't actually call it. If we wanted to call it, we could just write the name of the function, which will initialize it. Add the parentheses, and you can see it pretty much runs in all of this. So it's like, oh, this is what the interpreter thinks. My function. Let's see where it's defined. Oh, this entire block refers to my function. Let's see what it wants it to do. Okay, you want it to do this? Let's do that. And it just does that for you. So in the long run, functions can be a huge lifesaver, especially when working in big applications that really require all of this syntax. But now let's move on to another feature, which pretty much lets us add, subtract, multiply, and divide numbers, or integers really. So I can just fold this, go to the top, and create two variables. Let's give x a variable of 4. Let's give y a variable of 21. And let's say I want my function to add these two. Actually, in reality, we could just do print x plus y. Kind of like how in our English system, we would just say a number, then a sign, and then another number, and we'd interpret as that, and we'd say 6 plus 4 equals 10. So it's like likewise with the interpreter. So it'd be x plus y, and it knows x is 4 and y is 21. So actually what it's doing is 4 plus 21, which is then 25. So when I call this, it says 25. And this works with any operation. You can add a hyphen for subtracting, multiply, and divide. And you see we got that big decimal. So it's pretty interesting how this all works. And this is the very, very basics. So if you think this is as complicated as it gets, then you're far off, because there's more to it. You can actually do tons of stuff really. So there's tons of functions which create different models for you. They handle different actions which can incur other stuff. So yeah, that's pretty much the basics of Python. And now let's move on to some additional resources to further your learning. Finally, we will go over some resources to further your knowledge in the language of your choice. Remember, you don't have to do the step if you aren't satisfied. Instead, I highly recommend choosing another language that I suggested, or even do some research on your own on the internet, and find a language that sparks your interest. For those who'd like to continue with your language, I'm going to list some resources that are going to help you out. The first one is freecodecamp.org. Let me pull this up. So you can just access them by freecodecamp.org. As you can see, they pretty much teach you to learn to code for free. They have a lot of languages that they teach you. 6,000 tutorials, a lot of languages that are available. So it's pretty cool. I even used them for a little bit. They're really good. Secondly, there's from here the rest are just YouTube channels that I use. So the first YouTube channel that I recommend for making websites is a guy named DevEd. So he makes these funny, quirky web dev videos and makes pretty interesting tutorials, which I really like. So he's really good. Third guy is this is also for making websites. His channel is Web Dev Simplified. So he's also makes very cool videos. DevEd's more into the front end, where you do like what you see on the consumer side. Web Dev Simplify mainly goes around the back end, which pretty much handles logging in, creating all these different things with like REST APIs, databases, all this other back end interesting stuff. Then for making games, the channel is Brackeys. Not sure how you pronounce it. He makes very good videos about making games with Unity and C#, and he's a very good YouTuber. Really like him. Then there's a channel. His name is Computer Science. So that's his YouTube name. So he mainly does Python and sometimes, as you can see on his channel banner, C and C++, making these apps, and some Java as well. And then another channel is Tech with Tim. He mainly orientates around Python, maybe learning some languages with him, like live streams and all, and some videos about making mobile apps for Android and iOS. Then this is another just language channel that he teaches general stuff, programming with Mosh. So he makes quick videos, simple videos about, these are just some languages, about languages that he really teaches. He's more of an all-around person. Then the last two are mainly oriented around Swift development, but I guess some of these knowledge can be applied to Android Kotlin development. This guy, Code with Chris, he's a really good guide that I've been using for quite a while for learning iOS development. He teaches really well about how making iOS apps, and he's tons of videos from learning the basics to making a full stack application. And the final guide that I'd recommend is iOS Academy. Yeah, so he's also really good. He's one of the new channels. Makes weekly videos. Makes really interactive apps with custom maps. You see, he has like a chat app. It's pretty interesting. So he's really good as well. Yeah, that's all there really is to it. It isn't very complicated, and the process of finding your language and working with it can be fun and exciting as you learn about new things, and hopefully even make things for the world. In the comments, let me know what you decided to try out, and please specify if you want me to make a handful of tutorials for a certain language. Feel free to reach me out to me via the comments or my email, which you can find in the description of every of my videos. I hope you enjoyed this video and learned something from it, and I'll see you in my next tutorial. See ya!